So to start off, I'll go through epidemiology. We'll talk about some just general red flags, like with your children or with any child. At what point do we realize that something might be wrong? What do we watch out for? All the time parents will come in and they kind of get caught in that catch-22 is, I think they're smart, but I'm their parent. So it's like, where are they really? What do I think they are? Is that the same? I don't quite know. So we'll go through some developmental red flags. Then I'll go through basic functional neuroanatomy. They're not so basic functional neuroanatomy. And we'll run through, again, dyslexia, dysgraphia, dyscalculia, ADD. And then there'll be just some general ideas with regards to assessment. So what are learning disorders? Well, they're neurobiological, and it could really involve any part of thinking. So it's not just attention or multitasking or impulsivity or reading. It could be phonetically driven. It could be spatial awareness. It could be social skills. Right? So there's a variety of different learning disabilities. And location is dependent upon function. And it could be understanding or using spoken language. It can even be coordinating movements. And roughly 8 to 10% or more of children have some type of learning disability. Actually, I think most recent studies, even as high as like 15%, could be quite high. Now, be mindful that ADD is far overdiagnosed. So, you got to kind of keep that in mind. But if you look at it from like a functional perspective, legitimately a lot of kids struggle. So one of the things that's important about learning disorders is that, again, it can involve multiple areas, including like writing, reasoning, math, listening, social skills, and so on. It is due to central nervous system dysfunction. So it's not strictly environmental. It's not to say that environment can't play a role, but there is a genetic, a central nervous system aspect going on. And it is not the direct effect of like a culture issues or insufficient instruction. Okay? So like you're not going to tell someone's dyslexic if they haven't been trained in reading. No, the brain has the ability to understand language. It may need to be taught, but when we're talking about ADD versus dyslexia or all these things, neurologically, central nervous system-wise, the brain lacks the capacity. So that's different than adequate schooling, right? So again, I wanted to be kind of clear on that as well. And there's kind of two major schools of thought, one of which is that it's a discrepancy between overall intelligence. Okay, so now we all have strengths and weaknesses, as we all know, but if you're generally an average guy and now you're mildly impaired in one particular area, that discrepancy has to be it's like a 12-point difference based on IQ. So there has to be a statistically significant discrepancy that thereby indicated it's a disability. The other kind of idea is that you just look for more patterns than anything else, as opposed to kind of that statistical thing. And I'm kind of in the middle. I have a problem where if you're 1 percentage point this way, now it's not a learning disability, really, So, but I do think it has to be significantly discrepant from overall how we're functioning. So like if you have to be generally at a certain level, and then that has to be lower than that. So why is that important? Because I'll have kids that come here and globally they're suppressed. Right? And so the parents say to me, well, aren't they dyslexic? No. Don't they have ADD? No. Yeah, but they have trouble reading. Yeah, but they have trouble focusing. Absolutely right. They have trouble with everything. Unfortunately, the child's not that bright. So all of it's suppressed. But that doesn't mean that it's just a series of disorders lumped together. Right? So a learning disability is, again, a discrepant ability compared to overall function. And sometimes, honestly, you can even see these things on CT scans and MRIs. Like sometimes you can actually see the damage. Typically, in those cases, it's more tied to singular etiology. So maybe you have fevers over 105, which, by the way, at that point the brain starts to die, tissue starts to die. So, like maybe you had fever which were too high, and maybe there was a fall, maybe there was trauma at birth. Like things that you could see. So typically, you'll see that, or abnormal development. So when we take a step back and we consider all the potentially overdiagnosed children, it's anywhere 15 to 20% of the population. So you figure 1 in 7 of Americans. And Americans do tend to get diagnosed at a higher rate than other countries. So you draw your own conclusions for that. Just going to let it go. The most common are actually reading and language. And so 80% of people with learning disabilities have some type of reading problem. Doesn't mean it's dyslexia, but maybe they can't focus, so they can't read. But they struggle to read functionally. About 80% of people with learning disabilities. Males more likely than female. I'm sure that would be not a shocker for anyone in here. particularly as it relates to ADD. But so males roughly 1.5 more times likely than females, and they do run in families, as I think many of you probably aware. So let's move on. So let's go into brain development, red flags. Let's get into things that are a little bit more interesting. So what are we supposed to look for? 0 to 3. What's supposed to happen? Now, how old are your children? Anyone?
10. 10.
So all 10. You should all hang out. So,
we have a 19-year-old that was undiagnosed.
Gotcha.
Going through everything.
Fair enough. Mine are itty bitty still. So, but I'll go through then the early stuff pretty quick. But so like by 6 months, like no big smiles. They're not making eye contact. You don't see that kind of matching your mood. So what you're hoping for at that age is the mirror neurons to be kicking in. And so that's like when they see the smile in you, they make the facial expressions. The neurons are mirroring each other. That's actually happening in the brain, that the mirror neurons are kicking in. So you look for things like that. And by 9 months, like back and forth sharing a sound, smiles. Again, I smile, you smile, right? Or even you could say at that age, the word smile, and they smile. They start associating that word or that sound with a particular movement, right? Interestingly, as the brain develops, how some of the personality disorders develop is through inconsistent development of the mirror neurons. So what I mean by that is, so like if you're sitting there with the baby and you're holding the baby and you say, oh, you look so cute, you're so happy and you're smiling, it learns that this is what happiness feels like, right? And the muscles feels like. But if you're doing that inconsistently, sometimes you're saying, oh, you're happy, sometimes you're angry, and if your affect continually changes, you're not positively reinforcing that. Those mirror neurons can't develop, and then we end up not having a real anchored sense of self. It's obviously more complicated. But from like a general kind of term, and then early on, that's really where that consistent approach matters, so that the child has fundamentally, from a central nervous system perspective, that kind of needs to be grounded. So by 12 months, no babbling or gestures. 15 months, no words. 24, 2 words, phrases. There are some diseases too as well, where children learn to talk and walk and so on, and then they lose those skills. Typically it involves seizures. It's a seizure disorder, but that does absolutely happen. From 3 to 5, it's trouble learning common nursery rhymes, things to that effect, a lack of like appreciation of rhymes. This is where like Dr. Seuss, right, is really popular, that kind of rhyming, that kind of rhythm. They also sometimes, children don't recognize the self as separate, so they refer to themselves in third person or things like that. They have trouble kind of understanding themselves. And they often will have trouble with, separation. So, when you drop off at school or at daycare or things like that. And also, like, they don't seek affection from you. They're not reaching out and seeking affection. I'm not going to get into the autism spectrum disorders today, but that's a whole other realm we can talk about at another webinar. All right. So from 5 to 7, continued difficulty learning letters. They're really struggling to form their own name. The trouble with the sounds and how they all hold together. Problems with motor skills, tying shoes, writing, clothes fastening. Speech doesn't have good rhythm. It's broken. Handwriting's poor. And at 5 to 7, your teachers are calling you all the time. You're getting heads up from school saying there's something wrong at this point. And it is always important that you look for consistency between home and school. So if there's different behaviors in one setting versus another, that immediately is a red flag that there's probably something environmental. It's at least playing a factor. It's not to say there's not something else. But if they're super calm at home and they're really acting out in school, something's happening at school. The brain has the ability, you see it at home, right? So there's something else going on. And so it's important that you analyze those. When I do my assessments, I always give teachers stuff to fill out, unless the kids are itty bitty. But, because you want to know, what are the teachers seeing? For older kids, it's going to be the academic decline, behavioral issues. The child will say they feel dumb, school avoidance behavior. Others will say they're just lazy, they're not trying. You'll see them study, but they're still failing exams. Self-esteem starts to go down. Avoiding homework, not turning things in. It tends to shift more to a behavioral issue as this kind of goes on over time, because it wasn't addressed. Now it's been internalized, and so then we have a behavioral reaction to it. So before I get into the brain and how it works and all the fun stuff, any questions, guys? Yeah. Again, your children are all 10. So, so we're going to get into functional neuroanatomy as it relates to learning. So who cares? Like, why does it matter? Because it gives us an idea of understanding like, overall how our child thinks, right? Not just how they score, but how do they think, and how do I reach them best? How do I guide them? How do I teach them to use their own brain without getting a bunch of meds, right? So one of my real problems is if you start really with little kids, like a stimulant, like that's fine. I understand that they need that frontal lobe needs to be kicked in gear. They're having trouble. They're acting out. But then how in the world are they going to learn? How in the world are they going to learn self-control? The function in the real world, you don't want them on medication for life. So if they're on meds, you sure better have a plan and be working with someone to teach them those skills, right? So in my world, that medication should be a Band-Aid. So you have the Band-Aid so you can work on what's underneath. If they're too scattered to get anywhere to teach them, fine, you put them on meds so you can work with them to teach them the skills, and the meds go, right? So obviously this is somewhat tangential, but I think it's important that we look at these things as opportunities to work with our children and teach them. You know, there is no magic easy fix. It's the brain. Like, it doesn't work that way. So if you're looking for that, you know, I'm definitely not your guy. But I think it's important that, you know, again, we work with our kids to understand how to work with them, that there's synergy between teacher and parent, you know, so it's like a full, consistent approach. So neuroanatomy is important because we can predict some challenges. We can understand, you know, what to do about it. So here's general what the brain looks like, okay? Can you guys see that okay? I'm going to walk. Okay. So as you see here, this one doesn't work on my screen. Shocking, right? So frontal lobe, the frontal lobe is far bigger than most people think. It really goes almost all the way back to the middle, right here. And then on either side of this line is a motor strip here that controls motor control on the opposite side of the body. And right behind that is a sensory strip that controls sensation on the opposite side of the body. Okay? So here's your frontal lobe. The way front is called the prefrontal, before the front. Okay? Now I'll go through all the different parts of it and what it does and all that. The green part's the parietal lobe. It's more spatially oriented. Okay, it's kind of in these areas. And you do have two hemispheres. This is replicated on either side. And this is the temporal lobe, looks like a thumb, and then there's your occipital lobe at the back. Okay, so we'll kind of flip back to this. Here's functionally, so you get an idea functionally, right? And so it's all pathways in which we'll talk about, but again, it gives you an idea. So reasoning, planning, organization, speech, that area is called Broca's. Over here is like personality. There's the motor strip I was telling you about, the sensory strip right here. Understanding hearing, vision, visual processing, you know, memory. So the brain is localized in that there are certain parts that are very key, right, toward a particular function, and then they operate along a pathway. So you can have damage to a functional area by hitting that pathway or by hitting that particular area. Okay, so just again a framework. The other thing to understand about the brain is what white matter is. So white matter is the wires of the brain. And the way it works is from the brainstem, it comes up with this, looks like a mushroom stalk. It's called the internal capsule. So it looks like a mushroom stalk. So it runs out and then it fans out like this, just like a mushroom. And then you have fasciculi. Fasciculi are bundles of wires. And those wires go front to back, side to side, and so on. But the attention circuits, particularly in the frontal lobe, have a lot of those wires. So we'll talk about white matter, and that's easy to remember, white matter wires, that we'll start with W. So white matter wires. So we're going to talk about the wires of the brain and how they connect. We're also going to talk about cortical areas. Cortical is the outside, subcortical beneath, right? So beneath the cortex. That's the cortex. The outside is mainly cell bodies, and then underneath is the wires, which we talked about, the white matter, which are the axons, right? Axons. So let's keep going here. So we're going to start with the frontal lobe, and if you remember, that was the big part, right in front, and then it goes to about here. So the frontal lobe is responsible for emotions, judgment, planning, and as you move more forward, it becomes more involved in executive functioning. Any of you guys ever heard that term before? Executive functioning. So an executive functioning is what an executive does, right? 12 things at once, got to think quickly, got to make decisions, got to manage all that stuff. It's the ability to execute our intelligence, okay? To execute our intelligence, and that's prefrontal in this area over here. Deep inside, then we're having to do more short-term memory and working memory. Working memory being holding information 3 to 5 minutes, right? So if I give you a bunch of numbers that go write them down in your car, I won't do that. But if I did that, that would be an example of working memory. And this area has a lot to do with higher cognitive functions, social behaviors, impulsivity, and so on. what's really interesting is it's the last part of the brain to develop, and it's also the part of the brain that differentiates us most from like monkeys and primates and things like that. So it doesn't finish developing the ages 25 to 28, and it's also the primary site of ADD. So that's kind of interesting when you think about it, because then you have all these people that quote unquote grow out of it. So then the question then is maybe they never had it, maybe they just had a frontal lobe delay. Maybe it just was slow to grow. So they were immature and they never actually had ADD, right? So there's a lot of that where it's a frontal lobe immaturity issue. And that's why, like, if you think about the difference between somebody when they leave high school and somebody at the end of college, like a 4-year span are so different. It's not just college, but that frontal lobe really is kicking in gear. It really is developing and growing during that time frame. So that's when you see so much personality, like maturation, and that is neurologically driven. So interesting about the frontal lobe too, if you have damage to the frontal lobe, typically depression's involved, and IQ remains the same in most frontal lobe syndromes. So it's like how you use your intelligence, So if you think about ADD, you can have somebody that's super smart, but if they don't focus, they can't use it, right? But they're still smart. So it's how we use and apply our intelligence. What's also interesting about the frontal lobes is the way that they sit. They sit on like these bony ridges of the skull called the cribriform plate, okay? It sounds all fancy, but what it is, so inside our skull is pretty smooth, with the exception of the parts of the skull curve around to hold in those temporal lobes, and to cup the temporal folds. And then underneath the front here, like if I was going to chop my head right here, there would be little bones that stick up like this, and my brain sits on top of it. The problem with that is, like, if you get a concussion, like playing football or whatever, or if you're in a car accident, the brain's sliding around, it sits in fluid. Like, it's not all tight against the skull, it's sitting in fluid, it's going to slide around, just grinds against the bones, just grinds. So the frontal lobe is the most sensitive area to damage, and particularly the orbital frontal lobe, which is that part that sits against that, and that's the part that's self-control. That is the site of obsessive compulsive disorder. It's implicated in some aspects of schizophrenia. It's very much implicated in ADD, right? If obsessive compulsive disorder is overactivated, right, you're too controlled. So then if there's damage to it, you'd have, right? It'd be the opposite, look more ADD. So that is one of the primary sites we see for concussion and things like that. So we want to look at personality change, immediate personality change, kind of disorganized thoughts, being impulsive. So one of the things we have here in our pediatric partners is we have a 2 screening system where it's outside of insurance, but it's like one of which is you just quickly screen for attention, about 15 minutes. So like, is there legitimately an attention issue, right? An executive functioning issue. You won't know why, because we're not going through like that whole, this whole huge process. But you'll know legitimately, like, is there an issue there? The second piece looks at all overall thinking. It does it in about a half hour, and it gives you an idea of where are we really. We won't tell you how, that kind of stuff, but it allows for the physicians to get information very, very quickly as to what's going on. So that way it's not 4 months later, they're doing worse in school, and so on and so on. So in the frontal lobes, we see a lot of depression and things like that. And there are 3 parts to the frontal lobe. Do you guys see this in your paper? Mm-hmm. Okay. So there's the orbital frontal lobe. You see how it kind of is that flat part right there? And that's the part that sits right against that cribriform plate. And then you have dorsolateral, which is dorsal, right, top like a dorsal fin, lateral to the side. So that's these areas right in here. And then medial, which, is in the middle, right? And they all do different things. So orbital frontal, disinhibition, inappropriate affect, bad judgment, not very good insight, super distractible, antisocial personality disorder. That's where you have real problems with authority. Intermittent explosive disorder, relatively self-explanatory. People that have sociopathy, things like that. So it all seems to be damage to that area. As we switch dorsal lateral, right, up into the sides, that's truly your executive function. So that's your multitasking, judgment, that kind of stuff. It's also people that get really stuck on something. They just get real stuck on the percent rate. Usually it is indicative of damage to that area. And also some processing speed issues as the wires from that area connecting to the verbal centers are impacted. Okay. Medial frontal, that's deep, right, deep in the middle. It takes quite a bit to damage that area. Usually it's stroke. It's an anterior cerebral artery stroke. You hit there's a blood vessel that goes directly in there. But anyway, it can be apathy, and these are children. When you have it with children, like, they don't want to do anything. There's zero motivation. They're totally apathetic. They don't care if things are taken away. There's just nothing. So it tends to be quite significant. You can have damage to these areas too with things like viral meningitis and things like that, where there's edema or swelling in the brain, which then puts pressure on different areas. So we do see, I've seen some cases of that as well. So the frontal and temporal lobes are directly connected, right? They're right next to each other. And are you guys right-handed or left-handed? Right-handers, raise your hand. Okay. So 95% of people that are right-handed have language in the left side of the brain. Okay, and 5% or less have language on the opposite side or on both hemispheres. Okay, people that are left-handed, it's about 80% also on the left, and then some people have both, and some people have it on the right. So it does give me an indication right away overall how the brain's structured. Sometimes in here I'll say left hemisphere versus dominant, but always I'm talking about the language-based hemisphere. Okay, language-based hemisphere. So the temporal lobe is directly connected to the frontal lobe. So if the frontal lobe's attention has to attach to other things, right? Does that make sense? So attention has to attach to language centers. Attention has to attach to spatial centers. Attention has to attach to memory centers. And attention has to be related to emotion, right? So all those are wires from the frontal lobe connecting the different areas. So when you connect the language centers and the attention centers, there we can have problems in memory, expressive speech, things like that. So when you have damage to the temporal lobes, you truly have a wide variety of problems. Everything from problems with hearing and perception to attention issues to visual perception problems. This is the absolute primary site of all your dyslexia. All your language issues are going to be in that temporal lobe. Yes, ma'am?
You keep talking about damage, which makes me think, of an injury or something of that nature, but are we also talking about just developmental issues?
Yeah, because it's still damaged. It's still abnormal development of the brain. Yeah, and so yeah, absolutely, yes.
Can you repeat the question to that?
Yeah, so the question was, I keep talking about damage, but we're talking about learning disorders and disabilities. So does that apply? And the answer to that is yes, because it's the same brain. And so
it doesn't have to be an injury.
It does not. No, it can be congenital or developmental.
Okay.
Yeah, exactly. Correct. No, it's a good question. It's a good question.
Because I keep thinking to myself, when did he hit his head?
Yeah.
That's not okay.
No, but it may be like that part of the brain didn't develop the way it was supposed to, and because of that, now you have some of these symptoms. Okay. All right. Excellent question. So temporal and parietal lobes, when those areas aren't functioning as well as they should, we could have reading difficulties, dyscalculia, and that's the problem with math. And that could be due to the spatial problems with math, where you don't understand what the symbols look like or numbers look like. It's a perceptual issue, or it could be more of a inability to understand mathematical concepts. And those are different parts of the brain and how they connect. So switching to the parietal lobe, and once I get through all the lobes, then I'm going to bounce and we'll go through each individual disorder. Okay. So in the parietal lobe, that's again this area kind of over here, and that's more spatially oriented. And that has to do with some speech, but it's more visual perception. And weird things are in space, visual memory, things to that effect. I can tell you mine is not well developed. I can get lost in my subdivision. So, for those of us that have a terrible sense of direction, our parietal lobe, it doesn't work great. And that's okay, because we all have strengths and weaknesses, right? But that is strictly parietal. All right. So that's kind of the overview of the brain. So I'm going to flip back again. So we have frontal lobe, temporal on the sides, parietal, which is up and over here, and occipital's in the back. Occipital is more vision, so it is vision. And actually, right there in the middle is V1, and that has to do with central vision. And then the way it functions, it goes out in rings. And those rings have to do with color vision, and then you get to V3, V4 is movement, and then you get to color integration. And so, obviously I'm tangential, but there is in adults, there's something called posterior cortical atrophy. It's it's a dementia, like an Alzheimer's, but it strictly affects the vision deficits. The vision centers, occipital lobe first. So typically the first sign is you can't see movement. So I've had 2 patients come to me in the last year for it. Both of them, where they were golfing, they couldn't see the ball move. And it was that ring of the brain start to break down. So they couldn't see that. And then it moves back, and eventually you go cortically blind. The eyes work, but the brain can't see. But regardless. So now we're going to switch. We're going to switch to learning disabilities, and we're going to go through 4 of them. And then I'll give you a brief summary of some others. So let's talk about ADD. ADD is a disruption in the arousal attention concentration system. Okay? You may or may not also have another learning disability. Many people do. So often people have more than one. Okay? And particularly the dyslexia and ADD go together, and ADD and developmental coordination disorder. Okay? Now, developmental coordination disorder isn't something I go through explicitly in here, but these are children where the brain has trouble controlling fine motor coordination, and so and it's partially a deficit to how the cerebellum, or the back part of the brain down here, grows. And those are kids that are really clumsy, or that like can't seem to tie their shoes. And what tends to happen is there's a lot of peer avoidance in those cases, because you can't like keep up, and you don't want to be embarrassed. And then we have social issues and attention issues, and it kind of bundles into something bigger. The other thing I want to mention is central auditory processing disorder. I found a number of kids that have been diagnosed with ADD don't have it at all. It's a hearing issue, and it's called central auditory processing disorder. And basically what that is, it's like everywhere you go, it sounds like you're in a crowded bar. Like you can't filter out noises. Everything is here all the time. So it looks like ADD, but you can't focus. But you can't, because there's freaking noise everywhere, right? So it is important, if you notice hearing issues in your child, they're not attending right, go to an audiologist, or an ENT, and at least get that screened out. It really is far more common than I think people give it credit for. And again, I've got several recently. So moving on with ADD, it is a disruption of the arousal attention concentration system. You may or may not have an additional learning disability. And it's associated with dysfunction in the right hemisphere, non-dominant hemisphere, or both frontal lobes. And it could even involve the reticular activating system. Reticular activating system in the brainstem is like these group of cells, and they're the fundamental basis of attention. So like if you're driving in your car, and all of a sudden you get in a car accident, and that seatbelt's holding you, and your head goes forward, the wires in that, remember I told you it looks like a mushroom stalk, right? The wires in that mushroom stalk can shear. It's actually the most common reason for death after a car accident. Is that accidental shearing in the brainstem. But what you're doing is you're knocking out that strip in there that's for attention. So the reticular activating system, or the RAS. So what's important there, though, is sometimes there's fundamental problems with attention, and it's not all frontal lobe based. And in those cases, we look for other brainstem abnormalities. Some people are sick a lot, trouble regulating their own systems, things like that. Also, within ADD, development of inappropriate levels of inattention, impulsivity, overactivity, and it may involve the dopaminergic system or noradrenergic system from a chemical perspective. So as many as 49% of boys, 27% of girls are described inattentive by their teachers. I didn't say they have ADD. I said they were described as inattentive by their teachers. 50% of people do not have ADD. So that shows you that there's a whole lot of teachers complaining the kids aren't listening or they're inattentive, as compared to the serious deficits, 10%. So 50% have complaints, 10% actually have. So again, I think that gap gives you an idea of kind of where we are, right? And so again, I'm not going to go into a diatribe on that. But serious deficits occur 3 to 10% of school-age children, and it's the most prevalent of all neuropsychiatric, neuropsychological deficits is ADD. You also see it though. When else do you see attention problems? Autism, depression, cognitive disorders, dyslexia, leukemia, epilepsy, lack of oxygen, hypoxia, tics disorders, Tourette's, lead poisoning. So you see like all these different things can cause attention problems. So it's not always ADD at all. Sometimes, the first step is to know, do we legitimately have an attention problem? The second thing is to figure out why. And the immediate cannot be ADD. There's a huge variety of things that can cause it. ADHD is the most commonly diagnosed childhood disorder, about 5 million children in the U.S. Boys more than girls, we all know that. And I think legitimately it's roughly 10 to 12% of boys, 6% of girls. So again, 50% is what the teachers are reporting. It's probably closer to 6 to 10 in that range. Girls are different than boys. Boys tend to be super hyperactive running around, being boys, right? And girls tend to be more messy, disruptive. And so, it's kind of, I think, hard to get a feel for the true gender difference, because the boys are going to be called out more in class, right? Because they're disruptive, they're running around. So the teacher is going to be more likely to say something about the boy, I think. It's interesting when you get into adulthood, it's internalized. So typically we find that hyperactivity often goes away. And you have internal hyperactivity, so racing thoughts, disorganized thoughts. It goes on. You're still hyperactive. You're just hyperactive in here, right? They call it the messy person. But the super disorganized, messy person. What is in there? You know. Anyway, so within ADD, the literature varies whether there's subtypes or not. I think it's important that we conceptualize it as a predominantly inattentive, a predominantly hyperactive, combined. And there's this other type, and this is something that is in the literature last decade that we're still like trying to figure out where to put it, and that's sluggish cognitive tempo. So this is interesting. So there's a subset of people out there that are just slow processors, good problem solvers. They attend okay, they multitask okay, but they're slower than they should. In fact, their wires of the brain, that processing, is significantly discrepant from their overall function, like we talked in the beginning, right? That model. So the question is this ADD? Is this another type of ADD? The connections to that frontal lobe are what they're supposed to be? Or is this a whole other learning disorder? We don't know. You know, honestly, we don't know. And frankly, on my end, I don't really care where you categorize it. I care that you recognize that this is legitimately disorder. Because I get a lot of kids that end up with this. Where, yeah, and usually how you find it, like how they manifest, is they seem okay at home. But then they're getting in trouble at school. Because at home's not timed. When you work with them, it's not timed. They seem to focus. They're doing all right. They're good kids. And they're at school and they're really struggling. Because it's timed. It's pressured. It's a processing speed issue. So that's why it can be apparent. So if you want to check this out without going through all the formal testing, time them at home. See what happens. Right? Take that approach and see, what's happening. But that sluggish cognitive tempo is legitimately something I think we all need to be, mindful of. What does the brain look like in a child with ADD? The brain's smaller. The frontal lobe is legitimately significantly smaller. There's delayed cortical maturation in the frontal temporal regions, right? It's slower to grow. And in the basal ganglia, the caudate nucleus. Caudate nucleus has to do with short-term memory. It's an area of the brain called the limbic system, which is homeostasis, olfaction, memory, and emotion. It's kind of the entry point into that system. And the basal ganglia is the primary site of Parkinson's disease, and it's fine motor coordination and motor automatisms, and has some role with automatic processing in general. So what does that mean for an ADD kid? Always on the go, right? Always moving, can't quite control it. Basal ganglia, automatic motor control, right? The caudate nucleus, memory really varies. They're not good about controlling their emotions. Sometimes they appear to have selective memory. Right? And so, but legitimately the brain doesn't function the same way. So, you have the behavioral issues, but then you also have true central nervous system issues, that are affecting this. And so you can have quite a bit of differences between one child and another. One may have the sluggish cognitive tempo, one may not. So just because they have ADD, your approach is different, right? The other question I get asked all the time is, yeah, but they can play video games or be on an iPad for hours. They don't have ADD. Okay, but what does that do? It stimulates every which way. So internally, they can switch modality. So they're actually not paying attention. They're hearing, they're moving, they're seeing. It's coming in. So really, they're going, oh, I'm paying attention to the sound. I'm paying attention to this. I'm paying attention to this. Now I'm paying attention to this. So it seems like they're super focused, but they're not going. Right? So that's why these kids can play hours and hours and hours of video games, but then they can't focus at school for 5 minutes because they have to focus on one thing, right? On one thing. It's not they're not being stimulated by so many, by everything all at once. So what happens in ADD chemically? And then I'm going to go through the different pathways of attention. There's a delayed maturation of certain dopaminergic neural pathways. So those are dopaminergic, meaning dopamine. And there's an imbalance between noradrenaline and dopamine. And they both have to do with impulsivity. And dopamine is also directly tied to attention issues. And there may also be a problem with glutamate. Glutamate is excitatory as well, but the literature isn't as robust on that. So functionally, there's activation abnormalities with ADD for children, adolescents, and adults. And so what we do is you do fMRI studies, and you see, does the brain light up the way it's supposed to, right? You're doing certain tasks, and it doesn't. And it doesn't in the front part of the brain, and it doesn't with the wires directly, connecting that frontal system. So not only is it smaller, it doesn't activate as much as it's supposed to. And it doesn't metabolize the way it's supposed to. So particularly like glucose and oxygen are metabolized as well. So it doesn't work as well. Neurologically, it's not functioning the way it's supposed to. The wires aren't doing what they're supposed to. Those cell bodies, those cortical areas aren't doing what they're supposed to. And the difference in kid to kid depends on the anatomy, right? Is it more orbital frontal, the impulsivity? Is it more dorsolateral frontal, more problems multitasking? Is it more self-regulation? Is it more motivation, right? And so you start to see how all this is anatomically driven. And there's an atypical functional network. And particularly we're finding there's an atypical functional network in default mode. So like even at rest, the brains are different. Not even when they're activated, just at rest. The chemistry in the brain is different. So this is a very easy to understand slide. Sorry, guys. Anyway, so being sarcastic, these are all the functional circuits involved in ADD. Okay? So let's go through this. So here's our frontal lobe right here. And not only do I have to do this, I have to do this upside down, so this will be interesting. Okay, all right. So here's our frontal lobe here, and you can see there's the frontal cortex lit up in blue. Okay? And so that area has to do with our ability to focus and attend, right? The stuff we've been talking about with attentional systems. And that connects, that should connect, right? Our attention should connect to everything. And it does. It connects over here to the cerebellum that has to do with motor coordination. So if you have a break in this system, then you have, some of the motor issues you see with children with ADD. It connects to the thalamus, which is this purple thing here. That's the sensory relay station. So you can have sensory issues. Pretty much everything runs through the thalamus. It runs through the basal ganglia, which is motor planning, automatic processing. And it connects to spatial attention, right? Attending to where things are in space. You ever had your child where it's like they don't see things right in front of them, right? So like spatially, they can't attend to spatial things. And actually, when you look at attention systems, there's a dorsal and ventral stream. And so the dorsal stream is going to be attending to spatial objects, where things are in space, where things are on paper, or like, more visual. And then you're going to have the what, which is what they are, right? Attending to what things are, matching that. And it's all interconnecting systems. So in ADD, you can have a breakdown of any or all of these, right, neurologically. And which ones you're hitting will therefore determine what's the symptom presentation. So functional abnormalities. The reason this is in here is, one, to notice there's a difference between adults and children. And so I think my personal kind of conceptualization of this is that you have people that have a developmental delay of the frontal lobe, and then you have people that have ADD. Now both may need to be treated, but you have one that's developmentally, it's delayed, and so at some point it goes on and develops somewhat the way it's supposed to, or otherwise it doesn't. So I think there's a difference anatomically between those. But as you see here, there's specific gyruses, which are folds in different areas of the cortex. I know you don't know what all those are, but you do see it's, they're talking about kind of more the frontal lobe and things to that effect. And also when it's a cingulate, that's memory centers. Okay. And again, this is under versus over activation. So if you see on that chart, there are parts of the brain that are doing more than they're supposed to, and there's parts that are doing less. Here's the reasoning behind it. What the theory is that frontal lobe isn't active the way it's supposed to, but you have to function. So then other parts step in, because this is how people are born. This is how they've developed. They develop with their brain not doing what it's supposed to. So then inherently other parts of the brain try to step in, right, to make up for it. And so what you have is you have some parts that appear less activated than they should be, and you have other parts that end up being overactivated because they're working hard to try to compensate. Okay, so that's what that chart is really summarizing, regardless of what part is what, that system is what's happening. Things aren't working right, and then you have an inherent neurologic compensatory mechanism. So genetics, let's talk about genetics. 30 to 35% of ADD have an immediate family member with it, and specific dimensions are heritable. So impulsive dad, impulsive kid, inattentive dad, inattentive. Or mom. Messy purse mom, messy purse mom. Genes affecting dopamine, there's the DA1 gene, which is the dopamine transporter gene. It's directly tied to it. But we also have linkages to chromosome 5, 6, 10, 12, 16. We don't exactly know how or why, but we know there are chromosomes and genes directly tied to it. Frankly, it runs in families. So dyslexia. Any questions on ADD? There's probably a lot of information you didn't know existed.
One question.
Yes, ma'am.
So sometimes it's ADD, and sometimes it's just developmental delays.
Sure.
At what point can you make that determination which one it is?
So generally the way that I see it is as I assess like a child over time, and usually I do yearly evals because the brain's constantly changing, right? I'll see the pattern discrepancy start to grow. You know what I'm saying?
Yeah.
So if I catch them at like 7 and they're hugely discrepant in terms of that, and then 2 years later they're closer while the brain's developing and catching up, right? Or other times the brain doesn't change but function improves. So like if you catch a child early, you give them medication, you do different things, and you work with them, functionally they can absolutely do better. The brain doesn't change though, right? The brain doesn't change because it's again chemically not doing what it's supposed to. So I look for those patterns. But typically, you know, in all honesty, you treat them mostly the same. But it helps you know, at least to predict, you know, hopefully when they get to college, they'll all grow this. It looks like that's going to happen. You know, it gives you some predictability as opposed to saying, you know, these are challenges we'll face for life. Dyslexia in particular is like lifelong. You know, ADD, you have some people that grow out of it. People don't grow out of dyslexia. You have it, you have it. Okay. So let's switch to, oh, yes, please.
So eventually they could come off meds?
Oh, absolutely.
Okay.
Yeah. Yeah, and that's what's so great about that is, you know, the frontal lobe catches up, and so now you're at the point you don't need the medication. So, assuming they've learned the skills to self-regulate, right? That's a whole other animal. Yes, ma'am.
What do you think about it when parents decide to stop their children on their medication for ADD just during summertime?
I think it's a great idea.
Okay.
Yeah, because you know, I mean, you're going to break the cycle of addiction, and they're going to have to learn some actual social skills. You know, so, yeah. So, and plus that gives you a feel. If you think about the summers at the end of an academic year, it gives you a feel every summer. What are they like without their meds? You don't know, right?
But what if they're the same?
They might take them.
Yeah, exactly.
Can you just repeat? I'm sorry, just one more
Yeah,
time.
so the question was, if they're not on their medications and there's no change, should they be on them? The answer is that no. Obviously, that's something you do with guidance from your physician because you don't want to just stop one day and see what happens. But, you know, regardless, no. No. Now, like, I think that my personal opinion, the medication is going to have to help a lot to be worth it to take it. If it helps just a little, it's probably not worth it because you're going to have a whole other thing that goes along with it. So, particularly if you're going like hardcore stimulant, you're going to have potential sleep issues, weight loss, you know, often mood swings, increased irritability, anger modulation problems. I mean, these are your typical side effects. So, and it's addictive. Ritalin, Adderall.
What's your opinion of a hardcore stimulant?
Adderall, Ritalin. Yeah, those are your top 2. Yeah, those are like because usually what we do is you start low and you tier up. And it depends how low you go, depending on what's going on. So, like you may even start with like a SNRI, selective serotonin norepinephrine reuptake inhibitor, Cymbalta effects or something like that, because of the way it stimulates the frontal lobe. It's also good with kids that are a little bit anxious too. Then you can tier up to a mood stabilizer, which will be Wellbutrin, which is used all the time. Wellbutrin's good because it gets rid of a lot of those mood swings. There's some evidence to show the kind of paradoxical effect on agitation, gets more agitated. But it's not super addictive, and it really stimulates those dopamine centers in the frontal lobe. So you get quite a bit of boost in terms of attention while you're stabilizing mood, right? And then you can go into your Vyvanses and things like that, Strattera, and then you can move up again, Concerta, and then you move up again to your straight Ritalin Adderall, you know. And so those are as strong as you get. That's essentially, you know, flooding the brain with chemicals. And so it could increase function, but it does so by, you know, strictly chemically. So there are no learned behavior to look, because chemically it doesn't for you know. But some people legitimately need it. They do. And the thing is too is even on that, like, you know, are they on the lowest therapeutic dose? The doctors seem to take two approaches. One of which is start high so people feel good, and so they buy into the meds, and then we'll see where we're at. The other approach is start real low, and kind of chip away at it. And that tends to lead to a whole lot of frustration, but frankly, I think it's a better way to go. You want to be at the lowest therapeutic dose, particularly as a child, you know. I mean, it might be different, like, you know, you're an adult, you want to make that decision yourself, fine. But as a kid, we want to keep our children on as little meds as possible and the lowest dose possible. So that would be generally my approach. So it's appropriate for you to approach the physician to say, hey guys, they seem to be doing all right on this. Can we go down 5 milligrams and see how they do, right? And if the answer is they can't handle it, well, at least now you know. So I think those conversations are really important. Okay.
There's a question here.
Yes.
If both parents work and have less time for children, does it increase the chance of ADHD?
No, it doesn't increase the chance of ADD, but it does increase the chance of attention problems. So if ADD is truly something that's central nervous system based, then that's not something you're going to change or not change. But if you're not home and the children are starving for attention and those type of things, then yes, you're going to have more problems. And if you're not around to teach them how to focus and engage, right? So yes, it increases the risk of problems. No, it does not increase the risk of ADD. Okay.
Thank you.
So let's flip on to dyslexia, guys, and then we can go back at the end and we can talk about ADD more, even on like diet and all that other stuff, what's hokey and what's not. A lot of it is. Anyway, going on to dyslexia. So dyslexia is unexpected difficulty in learning to read and spell, okay? And again, this is not due to inadequate schooling or sensory handicap or just an overall low intelligence. That's what FSIQ is, full-scale IQ. So overall, they're not that bright. There's a very specific problem with how the brain understands language. And reading involves several things, right? So reading involves visual processing, and that would be more parietal, like we talked about. So visual, you have to see it. You have to recognize it as a letter. You have to recognize it as a word. And then you have the word recognition. And then there's comprehension, how it all fits together. So dyslexia involves the word recognition aspect due to phonologic issues. So what are some kinds of reading errors? Disfluency, slow, halting reading, right? It's very broken. And it could be after each word. It could be like in the middle of a word. It could be based on sounds. Errors in function words or substitutions on little words. So like articles, prepositions. So interchanging an A and the B. Misreading things, that kind of stuff. Visual words, and that would be reading car for cat. Right? Visual words, like sight reading problems. So my 6-year-old now is going through, it seems like 80 zillion sight words. But it's where but understand the difference. So he's learning essentially both primary models of learning to read. So at this point, he's getting sight words, which operates on attention systems and visual processing, right? Visual memory, what it looks like. And the second process is how the brain processes sounds, how those sounds fit together, and how that then matches up with a stored anagram, right? So you have two very different neurologic processes that are going into his learning of reading, and you can have a problem with both or just one. And your intervention will be very different if it's more phonologically driven or if it's more that spatial deficit. And in fact, if it's more the spatial deficit, you're probably going to have a problem with that. It's the same process, right? That visual matching up, same part of the brain. So you see, as you start to understand how this fits, you get a lot of prediction. Oh, they're having trouble with this. They're probably going to have problems with math. They're probably. We can also have lexicalization errors, and that's reading non-words like boy, bim. Like the sounds are kind of there, but kind of flipping the lexicons. So this is the model of development in dyslexia, like how it ends up being a problem. So in this case, you start off with faulty genetics, or you start off with some type of could be a genetic mutation. It doesn't necessarily need to be something you passed on. It could have been a genetic mutation that led to this. It could be a chromosomal abnormality. It could be something at birth. Maybe they were anoxic and jaundiced. Maybe there was chronic earaches, and so the brain didn't develop what it was the way it was supposed to. Maybe you had a bunch of fevers over 105, and there was loss of tissue. Maybe the cord was wrapped around the neck, and so because of that, you had lack of oxygen to those centers during that critical phase of development. A lot of things can happen, right? Okay. But we have something that happened, and that led to a difference between how the language centers of the brain and the non-language centers were functioning. And in this case, it says left hemisphere, but again, we're talking all you're right-handed. So we're talking about the language side. And then you have, environment and different things like that affect it. So, maybe they got the right tutoring, maybe they didn't. It just depends. So at that point, we start to have problems understanding sounds at a fundamental level, right? How the sounds fit together, how the words fit together. And then it just blows up at that point, because then you start having behavioral problems and behavioral avoidance, and the words don't make sense. And for children that have such a fundamental problem, it can just go downhill pretty quick. It really can. And get behind very fast. So what are some of the statistics here before I go through more of the systems? Within dyslexia, 55% have problems with oral language, reading aloud, okay? Oral language, or even conversationally sometimes. 51% have language problems or language disorder, with reading deficiency. And then 56 have math problems. Now you understand why people with dyslexia tend to have math problems. It's that spatial pathway that gets hit, okay? And dyslexia and ADD occur in 40% of the time. So, it's huge overlap. If you have dyslexia, you probably have ADD too. And overall, it's 5 to 10% of children have dyslexia. And the reason that varies so much depends on who you define them. And you see that throughout the literature. Is it like strict criteria for dyslexia? Is the teacher said reading problems? Like how do you, But I think, again, the importance here is that it's not uncommon. And you recognize that there's different types. So let's talk about the kinds of types. So there's a surface dyslexia, and that's like you can read well by established phonological rules. Short words are easier than long, but you have trouble accessing semantics. Semantics are like previously stored information. So you have trouble with non-words, visual aspects of words recognition. You understand the phonics, but you don't understand how it all fits together, okay? And this is, in this case, like you would have, for example, normal language skills conversationally. You can talk fine, you can read fine, you have any problems. But then you have problems with like the spatial aspect of language. You can't see the words, how they go together. You can't see how the sounds get together. Like you understand the fundamentals, but you can't visualize it all, pull it together. So when you go to read, the brain doesn't look at that visual picture of those words, and it can't match that up with the storage of what it means. It sees it, but it doesn't switch over into like that fluid language. It's a spatial issue. And these issues tends to, and Gershwin syndrome is left-right confusion, acalculia, and then spelling issues. So math problems, spelling issues, left-right confusion. We often see in these cases. So that's what a surface dyslexia is. And it's because you're affecting more of the surface of the brain. Okay. Now, a deep dyslexia, now at this point you're going deeper inside to those language centers. In this case, you could read familiar words like nouns, but you make a lot of semantic parallaxias and oral reading. So that's a flipping of the words. So you see mud and you say sheep. You rely on imageability, concreteness, word fluency. So in this case, your perceptual skills are spot on, but there's a language problem. This is the opposite pathway. So you see it, and you don't have a problem with sight words, because if you just take the picture, you match the picture up with the stored information, bam, it's there. But the fundamental aspects of sounds and how those fit together, that part of the brain's not working. So spatially, you can do it. Phonetically, you can't. Think about how important this is in understanding what type of dyslexia your child has for intervention. Right? They can learn spatially or they can't. You should probably know that. Right? I need to go with sight words because they don't understand the sounds. So in order to get them functional in school, I need to hammer them with sight words. I need to back off of the phonics. They'll need a tutor for that, but this way I can help them from getting less behind. Or the opposite, I need to let go. They're pushing sight words down their throat in kindergarten, and you know what? They can't do it. They have a problem with the spatial awareness of it. So we need to be specific, really go after the phonics system while we work. So it really matters. It's not just all dyslexia. And then if they have the spatial problems, well, how else are they? They're going to have problems with spatial memory, right? So we should probably work on that. They're going to have problems with math. They're going to have problems with geometry later on. They're going to have problems with anything that is visually based memory and integration. So it's, again, understanding pathways. There's different kinds of spelling errors, too, phonetically inaccurate errors, where they add consonants or remove them. And then there's the reversal errors, bog, dog, and so on. Here's what's interesting. So in the media, right, it's always the flipping of things. Everyone can say, I flip letters, I'm dyslexic. That is so rare. That is all media or whatever. Dyslexia means problems reading. That switching, super uncommon. So just let that go. It just sounds cool. So people are like, yeah, I got it. So, all right. So let's run through some facts about dyslexia. So there's genetic and environmental factors. Usually it's the combination of both that can cause dyslexia. When I say environmental factors, understand I'm meaning like failure to thrive issues, things like that, where the brain isn't stimulated appropriately. Okay. Common characteristics, difficulty learning letter names, generally good at math and spatial tasks. So the most common dyslexia is going to be where that spatial pathway is intact and where that phonetic issues are apparent. So that's typically what you see. Most of your dyslexias are going to be your deep dyslexias. Okay? Obviously, from a preference standpoint, it's better to have the surface type because at least you have the fundamentals of language are intact. You know? But it may be associated with slow reading, slow writing speed, letter number reversals. You can't memorize math facts. That's important too. People don't see math problems as a sign of spatial dyslexia. But it can be. There's a higher rate of spoken language problems, articulation issues, things like that. You can also have problems like phonological decoding and problems expressing yourself to peers, and so on. So the mechanisms, brain mechanisms. Now you know why I didn't get through all the learning disabilities, guys. That's one of the major ones. Be here a long time. Brain mechanisms. In here, there's a developmental anomaly in the dominant hemisphere, right? That would be the language-based hemisphere. And specifically, there's asymmetry in the planum temporale, which is in the back. Okay, so here's your brain, right? My hand's your brain. Here's your temporal lobe right here, my thumb. Frontal lobe, brainstem. Okay? On this temporal lobe, right here in this angle, there's a place called the angular gyrus that has to do with hearing. Beneath that is an area called Wernicke's. Wernicke's is hearing and understanding. Right in front, right here, is an area called Broca's. Broca's is our ability to express speech. The area that connects it is a group of fibers called the arcuate fasciculus. The arcuate fasciculus is internal dialogue repetition. There's 3 gyri, 3 folds here in the temporal lobe. The middle and bottom one are spatial, like semantics. The top one has to do more with like integration. Okay, so there's a whole deficit within that system, and I have a visualization of that coming up. But so when I talk about these things, you know that there's literally the development of those areas isn't what it's supposed to be, particularly in that area around Wernicke's, right there, right, in that juncture. There's some evidence to say that the interconnections between the 2 hemispheres may not be as good. So like spatial stuff on this side isn't matching up with language stuff on this side, but that's definitely less supported by the literature. So developmental course, typically you have an early speech delay, some articulation problems, trouble learning like the names of colors, things like that, remembering phone numbers, even in preschool, and they don't catch up. So children that have this don't catch up. Now, that's not to say they're not functional. So many are capable of going to college, but in general, there's less years of school. You know, in general, there's less years of school. And some can learn to compensate to the point that they're almost not diagnosable. But if you ask them about it, they say they absolutely still have the same problems. They just figured out a way to make it work. Okay? So maybe they learn just to, again, operate strictly by sight reading. Maybe they sound things out. Maybe they, you know, whatever, but people kind of figure out a way. And that's because, you know, most of the time other parts of the brain are intact. In terms of history, what do you need to watch out for? High familial risk. It should be evident by 1st or 2nd grade. Super unusual for all of a sudden, 3rd, 4th grade, you start, now dyslexia shows up. It should have been there from the beginning. It is central nervous system based. It's not acquired. Okay. So some of the neural signature of dyslexia, this is interesting too. So this goes into that underactive, overactive kind of theory we talked about earlier, right? Where like if the brain doesn't develop the way it's supposed to, something else tries to step in to make up for it. It's the same thing in dyslexia. So we see an underactive in that angle part I told you about, the angular gyrus, and we see underactivity in that part of the brain, Wernicke's, which is understanding. So that's not doing what it's supposed to. You know, it's not active the way it's supposed to. And the frontal lobe is freaking out, trying to make up for it. So we see the inferior frontal lobe overstimulated. So then the frontal lobe has to do with what, guys? Attention. So it makes sense. You can't read, so your frontal lobe's like, focus, 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 right? You could do it, focus. So it's overactive. Well, in the meantime, this guy's still sleeping. So, okay, all right. Genes implicated, there's potentially abnormal neuronal migration, so where the genes aren't giving the right signals to the neurons as they migrate to the different areas during development. So not enough neurons basically end up in that spot, so they don't proliferate. There's not as much there, and that's why they say, you know, there's potentially a difference between like symmetry, why one side of the brain looks different than the other. And also the visual word areas, which is in the back of the brain, which I said is vision. So like how you see things and how it all matches up with language, that there can be a problem in that area. Okay. Does all this make sense? Yeah. This is the same lecture I did for med school, so I know it's dense. When you go into cerebrocortical microdysgenesis, and that basically says that the layers of the brain aren't what they're supposed to based on development. And so again, as you see gray matter abnormalities where there's decreased density in that part of the brain in the language centers, or the mirror neuron system we talked about in the beginning doesn't develop the way it's supposed to. But what's important about all this is like when people think of ADD and they think of dyslexia and these different things, they don't think of it this way. Like what is happening in the brain? Why are they struggling? What else might be going on? What's going to happen to them as they get older? So all this predicts that, right? And it truly is not just they're behind. Like neurologically, the brain's not doing what it's supposed to. So twin studies reveal the rate of developing reading disabilities 2 times higher in monozygotic versus dizygotics, meaning that the shared genes, the more genes you share, the more likely you're going to have it. Half of impairment in reading performance is due to genetics, 40% environment. Okay, so it usually has got to be a combination of both. And then there is a dyslexic phenotype. So actually right now there's like a genetic profile we're starting to find that could be directly tied to dyslexia with some predictive factor. So that's kind of where the research is now. Okay, so let's talk about this in really easy terms. Again, that was a bad joke. So as you look at the picture of the brain, you see 2 systems, right? You got this circle one right here, this red one. I'm going to turn this around so you can see. So you see this red one and you see the green one, right? Everybody else? Okay. So as you see here, this one right here, the anterior one, anterior being front of our brain, that's the frontal lobe. Frontal lobe's attention, right guys? So if you're having to deal with language, you're going to have to focus and direct your attention to a particular system. And if you can't direct your attention, you're going to have a problem. So we know this attention system is directly involved, right? And particularly, this has to do in the language centers here. So it has to do with like our ability to look at this versus this, to be able to attend to a whole sentence, how it all pieces together, all of that. And we also said it involves the verbal, the language centers here in green. Right? Our ability to understand is one particular part of the brain. Our ability to speak, one particular part of the brain. Internal dialogue, one particular part of the brain. Storage of information. Again, all that is kind of processed in that area. So we kind of have a problem there. And there's also the dorsal, the spatial part, which is more parietal, right? We can have spatial deficits. So when you think about dyslexia, there's problems with attention, either spatial attention or semantic attention, understanding facts, right, language. There can be a problem with actually the language centers themselves or spatial. And typically it's this network that is disrupted. The attention, language, spatial network. Okay? And depending on where you hit the network will depend how it shows, how it manifests to you. So that's what we were talking about before, right? And so now does this make sense why so many kids with ADD will have dyslexia and vice versa? Because if this system is out, we'll probably end up with one of these other things affected too. There's huge overlap because it doesn't exist where here's ADD, here's this. It's all these networks. Again, there's parts of the brain that are pretty localized, but it's all wires and systems. So you can knock out that system in a variety of different ways. Okay. So now the last one here will be dysgraphia. Dysgraphia is a written language disorder where you can't write. You can read it, but you can't motorically. It doesn't translate into the writing. And it's not just a developmental coordination disorder. Developmental coordination is globally poor communication, right, or coordination. This is problems truly writing words. And then sometimes it's disorder of written expression. But these are people that have again, they just can't like perceptually pull it together. And it could be with other disabilities and or without. So what do you see? Poor letter formation, too large, too small, it's inconsistent. Capital and lowercase aren't used right. You know, they're not spaced, like letters are cramped together, like they're not spaced right. They're not fluent, you know, words aren't finished, letters aren't finished. You know, but in the meantime, you ask them to read something, they're fine. They sit there, they can talk to you, they seem good, they seem bright, but then they just can't get it out, they can't write it. They can read, you can't write. Disorder of written expression. Okay? Usually what we do when we test for it, we have a picture that it's like a story of some people camping or whatever. And so you ask them to write what they see, right? So they write it all out. And then you ask them to describe it to you. They do a great job describing it. You look at what they wrote, it doesn't make any sense at all. But they get it. They obviously get it, and they can express it using language. They read the instructions on top. They said, look at this, write a story, right? I mean, so they can read, they get it, but the brain can't take that and control motor movements so that it all flows. Okay. So it truly is a processing problem, and it's difficulty in automatically remembering the sequence of motor muscle movements. So I used to be a really terrible typer. I mean, like, one finger at a time. So I got to a point where I had to do something about it. So I forced myself for about 3 years to type while my patients talk, or type their histories while they're talking. Now I'm at a point where I can have 3 people talking, I could be talking, I can type the whole time, right? So it's motor memory, automatic motor memory. Somebody with dysgraphia, that's not possible. The brain can't get that motor memory, even for writing letters. Think about when you write your name, like Jeremy for me. The J just flows, right? J-E-R-E-M-Y. It just flows. It's all automatic motor memory. You may think of the letter, but it just kind of flows out. So there's a disruption in that pathway, right? Also, there's a lot of writing fatigue. They can't seem to communicate. They don't seem to be organized, like on the page. And it's very much out of harmony with somebody's IQ. Again, you'll know they'll talk, they're smart, they can describe stuff to you, but then the writing is just... Anywhere between 7 to 15% for disorder of written expression. Boys more than girls. Boys are pretty much more likely to get everything than girls. Just you and I here. And Jeff, you too. But only 25% don't also have a dyslexia. So this is what's important. Somebody with dyslexia may or may not also have a disorder of written expression. Somebody that have disorder of written expression, 25% also have dyslexia. So a lot of these go together. Again, it's the same brain. So it makes sense. Most children with learning disabilities in reading and math end up having at least one area of problems in written expression. So it's important that we look at that. Okay. So the last one I'll cover today is dyscalculia, which is a focal math problem. By now, you should understand a little bit of where this is going to go, because you understand that there's spatial representations of things within the brain, and you have to match those up against, a certain set of rules, and you have to attend to it, and organize it. So you're starting to see these frontal, these different pathways. So it's no different in math. So in this case, people have difficulty understanding even simple number concepts. Like the brain just can't grasp how numbers all work together. They may even get the right answer, and they may even understand the method, but they can't mechanically pull it together. Underlying causes. It could be due to an attention issue. It could be due to memory, where they can't remember the rules, things like that. It could be processing speed. It could be motor control. It could be understanding concepts. All different pathways. All different ways. But dyscalculia is a standalone diagnosis. So you can get academic accommodations for strict dyscalculia. So here's a picture of the different activation. And again, here's the activation-deactivation model, where you have part of the brain that's not doing what it's supposed to, the central nervous system is not functioning the way it's supposed to, something tries to kick in, right? And you can see the frontal lobe, in this case, in the blue, you see the frontal lobe is being activated, it's just trying to focus, but then as you go back into those spatial areas, it's not doing what it's supposed to, right? So it's that same model, where part of the brain's not doing what it's supposed to, the frontal lobe freaks out, focus, 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 you could do it, right? So we see deactivation in one area and we see overactivation. But regardless, it's more parietal based. Math tends to be more spatially based, so it's more parietal in these areas. Incidence rates, 18% of 4th graders, 27% of 8th graders. And that's just showing that, that's just based on the national standardized testing. So that's not diagnosing dyscalculia, but it is saying that mathematic problems are super common. Right, super common. Often, again, you have problems with kind of words and spatial reading, things like that affect as well. So this is just a summary of some other learning disorders. Developmental coordination disorder we've talked about. Disorder of written expression we've talked about. There's also a sluggish cognitive tempo. Is it a subtype of ADD? Is it not? Doesn't matter. Just get help for it. There's also a non-dominant hemisphere delay. So we talked today about that language-based hemisphere, right? Right. Well, that exact same thing can happen to the opposite side. The exact same breakdown, the exact same problems, except that's not a language-based hemisphere. So when it affects that, that's when we have problems with, spatially oriented tasks. Math would be one of those, but it would be like my fantastic sense of direction, right? Or it would be things like I should never be a dentist or engineer. My whole family's engineers, my dad, my uncles, my brother. So I should never do that because I can't see it in my head like that, right? But my language centers are developed fine. So I think it's important to know that it's based on just how the brain develops. Typically, people with problems in that dominant hemisphere, that language-based hemisphere, are going to have far more problems in life than in the opposite side, just because we exist in our world through language, just by nature of that. So briefly, in terms of assessment, you need to have someone really take a look at these things in depth, and not just how they're functioning, but why. Because if somebody comes to you with a math problem, like if your child has a math problem, you go see somebody, you already know they have a math problem. Right? You don't need them to test and go, hey, they got a math problem. Really? I knew that, but you want to know why. Is it an issue with the spatial representation? Is it where they don't understand the symbols? Are there other spatial problems? Are there other deficits in visual memory that we're missing? Maybe it's a visual memory issue. What's actually happening, right? And then you need to make sure that your approach and the school's approach line up. So you want a 504, you want an IEP in place, you want to make sure that it's truly synergistic. And so, and you take a look at the social ramifications of these. Most children with learning disabilities have social problems. I mean, it's a full range from mild to severe. But, as we all know, kids aren't very nice. Yours are all 10. They're about to enjoy that, I think, a lot. That 10, 11 to 17's rough. And so you're getting things where people are more self-confident, they feel more behind, they start getting more avoidant in things, so you really have to step in, and you really need to track it every year, because the brain's changing. It's not like adults. If somebody comes to me for an Alzheimer's evaluation, and I find out they're fine, I don't need to test you next year unless you think all of a sudden something's wrong, right? With kids, you really need to check on them every year during those critical phases, because you want to make sure you help them every way you can. And different classes pull on different parts of the brain. Think about the difference between geometry and algebra, right? It seems like somebody always hated one versus the other. Geometry is terrible, algebra is fine, or vice versa. Totally different parts of the brain, right? Geometry is more spatially oriented, algebra is more language. It's almost a language you learn, right? You learn the formulas, different parts of the brain. So it's interesting as you think about it. Early detection matters tremendously, and most children aren't identified to 3rd grade, just so you have a heads up. Although, you really want to try to catch them in 1st and 2nd. That tends to be when you first really start to notice symptoms. But usually it has to escalate a little bit. Teacher has to complain, and then so typically around 3rd grade. This is just showing how quickly you can get behind when you start having hand motor control issues, poor social skills. You're not listening, handwriting's poor, reading's poor, and so on. And what that shows, age 5 and age 7, it shows, okay, by age 5, you haven't caught this. Now they're having trouble learning nursery rhymes, and there's some baby talk going on, and difficulty learning letters. Well, now at 7, they can't read, they're behind, right? They're complaining about reading, they're avoiding school. So quickly, it escalates quick, the nature of the problem. And there's a lot of comorbidity. So, if you say, they don't have ADD, they're just being a boy, well, okay, maybe, but there might be something else going on too. There's a reason for the behavior you're seeing. Maybe it's strictly behavioral. It could be, but you need to know. And if so, why? The rest of these slides are more of a summary of comorbidity and things like that. So I'm gonna open up now for questions. I don't know how long it's been. It's gonna get going. I'm about right. Does anybody have any questions for me? I know there was a whole lot of material, but I hope you kind of left understanding that it's all nervous system based, having some overall understanding of the brain, and particularly with this dyslexia and ADD, you kind of have an idea of the neuroanatomical and neurochemical underpinnings. Any questions, guys? No. So I can start asking you questions about it all? Just kidding.
Hold on, there's.
Sure.
Does memorizing help decrease ID, LD? I don't know if they mean ADHD.
LD?
Can you clarify? Does memorizing help decrease what?
Learning disabilities.
Learning disabilities, maybe?
No. So all these brain games, all this stuff you see all over the place, right, advertised, Lumosity, none of it works. So Stanford did a study, 2014 maybe, and did a huge meta-analysis of all of it, and found it does nothing. All that happens is you get good at the game. So, you know, if you think about it, right, so when you're driving somewhere, you're not thinking about driving, right? You're spaced out, or you're thinking about your day or whatever, right? And so how are you able to do that? Well, you're able to do that because the basal ganglia kicks in and you operate on automatic muscle memory. So the problem with those games, if you're doing the same task over and over and over, is it becomes automatic and all you do is get good at a game. Nothing happened at all, just like driving, right? But if you take games and you take things like that and every time you do it, you take a totally new approach, then there is evidence of neuronal growth and change. It kind of operates on the principle of muscle confusion for like exercise and bodybuilding. And that's the idea that I can do 80,000 simple curls and I'll get a certain amount of strength. Or I could do a third here, a third twisting at the bottom, a third one pulling here, and I'm stimulating the muscle in different ways, so I'm going to have far more functional gain over a much shorter period of time. It's the same way when we're using our brain. We want to stimulate it. We want to stimulate it. One of the real important things, honestly, is like nutrition, physical exercise. The brain needs all the oxygen and nutrients it can. If you have an 8-cylinder engine that's operating on 6, you got to keep the 6 working well. I mean, even when you look at, and this is with adults, Alzheimer's, right? If just by exercising 3 times a day, 40 minutes a shot, you can reduce the risk of Alzheimer's by anywhere between 68 and 73%. So, that active, that generally being healthy matters a lot. Any other questions, guys?
What about the diet for ADD?
Use your common sense. Yeah. So the question was about diet. So there's a lot of different opinions about diet and what to do and what to not, and certain foods help, and some parents will swear by it, some will tell you you're crazy. My personal approach is common sense. So you don't want too much sugars. You want to time the sugars when you get them. You want to try to eat as many fruits and vegetables as you can. Kids should not eat chicken fingers every day for every meal. I mean, would you? Gross. No. So I think there needs to be, I think if you take a real common sense approach, then you can absolutely see differences. I mean, how do you feel? You eat a bunch of fried food all the time. Sluggish and irritable, right? How do you feel if you eat 12 pixie sticks? I don't know, because you'd run out of here, right? I mean, you know what I'm saying? So what do you think is going to happen to a little kid? You give them all that stuff. I mean, if you eat pizza and chicken fingers all day long, you feel terrible. So, that's kind of where I'm at. It's good for us, bad for the kids. They're not happy about it. Then, do you have a question?
My question really is, I don't know how to find the proper treatment for my child.
Okay.
I feel like I'm floating out there
Well,
going,
tell me what's happening, and then I can guide you appropriately.
I feel like I'm going from one doctor to the next, and I'm just getting the same thing over and over again.
What are you getting?
It's ADHD, let's give him this medicine, that medicine, that medicine. And, when I listen to this, I think I see it so much deeper than that. So much deeper than, let's just give him medicine and get through the school day and be done with it. I just feel like I don't know which direction to turn to find a proper treatment, to find out if he really does have a learning disability.
I mean, I don't have a problem testing him. I mean, that's fine. I mean, it could be done in my office. There are other people locally, But yeah, I mean, I think you need a really thorough assessment. Like, where are we? And the problem is, so many people want the quick fix, and that's the problem. And so then you have this mentality of, oh, here, just take this meds. I mean, I'll get calls from pediatricians all the time. Jeremy, should I put him on meds or not? Like, the mom's driving me crazy. And and of course, mine is saying, no. You tell the mom, too bad. Go get an assessment. Let's see what we're dealing with, right? Or at the very least, let's screen for attention. Let me make sure this is real. And You know, you're not cropping your kid in a corner with an iPad and a Ritalin. You know, I mean, there's some crappy parenting out there. You know, so yeah, I would definitely take a serious look at it and see what do I actually have. You know, so yeah. Any other questions, guys? No. So I guess the last thing I'll just summarize kind of the partnership that we have with pediatric partners. And so what we have is that brief screening here for attention that's done in office, about 15 minutes, and it looks at the frontal lobe in particular. And so it'll look at orbital frontal lobe, prefrontal, dorsolateral frontal. So I'm looking at executive functions, multitasking, general attention. It won't tell you why, but it'll tell you like how the systems are functioning. And the cost on that is $50. It's, you know, patient pays, it's just done. It's just easier that way. The second tier here is a full assessment. It doesn't go through like all the learning disabilities, but it does tell you where legitimately is language centers, how are they functioning? Where are spatial centers? Where are memory? Where's attention? That's done here as well. That runs about a half hour, 40 minutes, and that's your cost $300. And then certainly you could submit to your insurance. You don't get it reimbursed. But that's just how we have it set up here. In my office, in my private practice, I do try to bill insurance. Often they don't pay, honestly. They try to tell you the school will do it. You know, they're trying to push it off the school will try to push it off the insurance. So anytime you come to me, even though I take all insurance, you know, you really need to call your insurance company and say, hey, do you cover ADD assessment dyslexia? I'll try to work with it, but, you know, and I work with parents when it's denied, but you know, you just need to be aware of kind of the world out there with regards to these things. So that's kind of what we have in place here. You know, certainly on my end, the full assessment is going to give me the most information, but it's going to take me a while to go through the process. And you know, sometimes you need to know now. Kids behind, people are freaking out. Like you need some information now. So those are the systems that we have in place, and particularly on the tier 1, we've gone through 40, 50 kids. You know, that we've put through that. And what's happened is, I would say maybe even a quarter of them didn't need any meds at all. So these are meds, these children that would have gotten meds, and now the doctor said no, because the assessment showed no, they can do it. Sorry, you know. But legitimately, we found a lot of them where there was really something going on and that needed to be addressed. So I just want to, you know, again, let you guys know that that's in place, and we're just kind of going to keep growing that relationship to try to, you know, be able to address these kids, all of them, you know, front end all the way through. So okay.